Hello everyone. Today we're going to look at basic operations in polar form. So if we FOILed out r1 times cosine of theta 1 plus r1j sine of theta 1, so one number in polar form times another one, r2 times cosine theta 2 plus r2 j sine of theta 2. I have an extra open parenthesis there, that's fine. We could use properties of sines and cosines and to simplify it. But I'm not going to do that out here because we really didn't get into a lot of different definitions or equations involving sine and cosine. So for now, just please believe me, I guess, and you can look at it in more details in another source. But what we're going to do is I'm going to use the simplified version of it, so that r1 angle theta 1 and r2 angle theta 2. So if I multiply two numbers in polar form, then we multiply their r's and we add their angles. So r1 theta 1 times r2 theta 2 is r1 r2 angle theta 1 plus theta 2. This comes from the fact that a third way we can write our equations involves theta being an exponent. So rules of exponents would be if I'm multiplying, x to the a times x to the b, then I would add the exponents. So that's kind of a little bit of a hidden background there. Similarly for division, I would divide my r's and subtract my thetas. So I'd have r1 over r2 with an angle of theta 1 minus theta 2. Something to keep in mind is that we always need our angles in the range of 0 to 360. So if we have a negative angle, we need to find that corresponding coterminal angle that is between 0 and 360. And if my angle is over 360, again, I need to find that coterminal angle. So really what that boils down to is if you have a negative angle, you want to add 360 to it. And if you have an angle bigger than 360 degrees, you want to subtract 360 degrees from it. And notice that we have equal to 0, but strictly less than 360. And that's because 360 is coterminal to 0. So let's do some examples. We have our first complex number is 30 with an angle of 65 degrees. Our second one that we're multiplying is 10 with an angle of 200 degrees. So we're going to multiply our r's. So 30 times 10 is 300. 65 plus 200 is 265. For division, and we're going to divide our angles. So 40 divide our r's, 40 divided by 8 is the 5. And then 50 minus 100 is negative 50. But again, we can't have a negative angle, so I'm going to add 360 degrees to it. And my final answer would be 5 with an angle of 310 degrees. Here's another one with division. We have 20 with an angle of 215 degrees divided by r being 40 and the angle of 180 degrees. So again, I'm going to divide my r's. So 20 divided by 40 is a half. And then I'm going to subtract my angles. So 215 minus 180. It'll give me 1/2 with an angle of 35 degrees. Next, I'm going to multiply 10 with an angle of 250 degrees and 2.5 with an angle of 312 degrees. So I'm going to multiply my 10 and 2.5. That'll give me 25. And then for my angle, I'm going to add them together. That's going to give me 562 degrees. That's too big, right? That's not between 0 and 360. So I'm going to subtract 360 from it. And we get 25 with an angle of 202 degrees. My angles of my polar form won't always look like that r angle theta. So here I have 10 cosine 20 degrees plus 10j sine of 20 degrees times 3 cosine 40 degrees plus 3j sine 40 degrees. I don't want you to try to FOIL this out. Okay, what I want you to do is to recognize that's still polar form. So what I'm going to do is I'm going to translate it into that shortened version. There we go. So 10 with an angle of 20 degrees and 3 with an angle of 45 degrees. Now I'm going to recognize, okay, now I want to multiply my r's and I want to add my angles. So it's just 30 with an angle of 65 degrees. Okay, so even if it's written out in the long form, remember, that's still polar form, and all I really care about are the r and the theta. Same is true if it's written as division. This looks really complicated, but remember, those are just polar form, so I'm going to translate it into that shortened version. So my r is 4 for the top, my angle is 60 degrees. My angle on the bottom is 200 degrees, and my r is that invisible 1, right, that coefficient of cosine and j sine. So I have 40 with an angle of 60 degrees divided by 1 with an angle of 200 degrees. So I'm going to divide my r's, and I'm going to subtract my angles. So 4 divided by 1 is 4. 60 minus 200 is negative 140. And again, we can't keep a negative angle, so I'm going to add 360 degrees to it. And that's going to give me 220 degrees, and still with an r of 4. Next, we're going to look at what if I have a polar form raised to a power. So if we remember, powers are multiplication. So if I know how to multiply, I know how to raise it to a power. So first I'll just do the definition of something being cubed. It's something times something times something. Every time I multiply two numbers in polar form, I'm going to multiply their r's. And again, I'm going to add their angles. So I'm going to do that for all three of them. So my r would be the 3 times the 3 times the 3. My angle would be the 40 plus the 40 plus the 40. So that'd be 27 with an angle of 120 degrees. And if I want to look at that in general, I'm taking the r and I'm raising it to the n, the given power, and I'm taking the angle and I'm multiplying it. Because 3 times 3 times 3 is 3 cubed, and 40 times 40 times 40 is 40 times 3. Okay, so if I have a polar form being raised to a power, I'm going to raise the r to that power, and I'm going to multiply the angle by that number. And then here's another one with division. So again, it looks like it could be complicated, but it's just polar form. So I'm going to rewrite it. So I have r is 8, theta is 180 for the top. For the bottom, I have r is 12. Right, I have it factored out for both of them, so that's still r, and that's still 12. And then my angle for the bottom one is 90 degrees. So I'm going to do 8 divided by 12, and I'm going to take 180 and subtract 90. 8 over 12, I can cancel a 4 in common, so that's 2/3. 180 minus 90 is 90, so I have an angle of 90 degrees. In order to do addition and subtraction, it's gonna involve a lot more work. And this is, again, where it's helpful to remember that numbers in polar form are very much equivalent to vectors that we did in Tech 1. Remember, if I wanted to add vectors, I had to first deconstruct them into their x and y components. I had to resolve the vectors into their x and y components, add those, and then put it back into vector form. That's going to be the same thing here. We need to convert from polar to rectangular, then do the addition or subtraction, and then put it back into polar. So for our first one, we have 40 with an angle of 30 degrees plus 3 with an angle of 200 degrees. So we're going to convert them into rectangular form first. And that's really just going back to that other definition of polar, right? 40 with an angle of 30 is, by definition, 4 cosine of 30 degrees plus 4j sine of 30 degrees. And then similarly, the 3 with an angle of 200 degrees is 3 cosine of 200 degrees plus 3j sine of 200 degrees. So that's still technically in polar because we still have r and theta. So when I plug those into my calculator, it's going to turn them into rectangular. So again, we're going to round to the nearest hundredth. So just plugging those 4 into the calculator, I get those guys. Right, so these are all strictly equivalent to each other. And now I'm adding two numbers in rectangular form. If I'm adding, I can just ignore the parentheses, combine the reals, combine the imaginaries, and that's going to give me 0.64 from my real part and 0.97 for my imaginary part. Now I need to convert it back into polar. So we're going to use those equations that we had before, right? R is the square root of a squared plus b squared, and theta reference is tan inverse absolute value of b over a. So using those guys, we get that R is 1.16. Theta reference is 56.58 degrees. Now, A is positive, B is positive, so that means we're in quadrant 1, and that means my reference angle is my angle. And I can put my final answer back in polar form, so 1.16 with an angle of 56.58 degrees. Okay, so these steps are a little bit longer. We kind of got to do a bit of everything, but it's not hard. And again, it is the exact same thing that we did with vectors. The only difference is here we might be subtracting. We didn't subtract vectors in Math 125 Tech 1, but it's going to be the same thing. We know how to subtract numbers in rectangular form, and that's really all that matters. So in the first thing I'm going to do is I'm going to start rewriting it so that it looks more like rectangular form. So 25 with an angle of 100 degrees is 25 cosine of 100 degrees plus 25j sine of 100 degrees. We'll do the same thing with our 30 and 50 degrees. We'll plug all four of those into the calculator. I have subtraction here, so I need to make sure that I am distributing that subtraction when I start combining my reals and imaginaries. So negative 4.34 minus 19.23 gives me my negative 23.57, and then 24 minus my 22 gives me my 1.64j. Okay, so again, make sure you're subtracting both of those pieces. So again, using those same formulas from before, R is going to be 23.63. Theta reference will be 3.98 degrees. Hopefully that makes sense. My X or my A is a lot bigger than my Y or my B, so it's going to end up being a smaller angle. It is also in quadrant 2, like I have it drawn, right? My X or my A is negative, my B or my Y is positive, so it is quadrant 2. So my angle is 180 degrees minus that reference angle. So we get 176.02 degrees. And I'll put it together, and my answer is this polar form of 23.63 with an angle of 176.02. For the last one, I have 10 cosine of 285 degrees plus j sine of 285 degrees minus 15 times cosine of 150 degrees plus j sine of 150 degrees. So it's already in that kind of elongated polar form. So I've kind of already done that first step for us, and all I have to do is start plugging this stuff into my calculator. Remember that this 10 is outside the parentheses, so it has to be distributed. The same thing with that 15, so don't forget those r's go with the sign as well. If I plug those in, I get 2.59 minus 9.66j minus a negative 12.99 plus 7.50j. And again, I'm going to make sure I distribute that negative across both terms on my right. So I have 2.59 plus 12.99 gives me my 15.58. And negative 9.66j minus 7.50j gives me my negative 17.16j. So using those same formulas, R should be 23.18. Theta reference will be 47.76 degrees. My angle is going to be 360 minus my reference angle because I have a positive A a negative b, and that is quadrant 4. So I'm going to take 360 minus, again, my reference angle. That'll give me 312.24 degrees. And then my final answer is 23.18 with an angle of 312.24 degrees. Okay, the biggest thing that I see people mess up on is they won't distribute that r to the second term, which is sine, and also they'll do funky things with that negative. So leave it as subtraction and keep the parentheses, and then distribute the subtraction after you've changed completely from polar to rectangular. Okay, something funky usually happens with that subtraction sign sometimes, so just be really careful on that. But that's the last one, so make sure you read through the book and let me know if you have any questions. Thanks.